Hello everyone, in this video I will show how to add elements to a binary search tree, as well as a coding example with an explanation on how recursion works. A binary search tree is a binary tree where all elements to the left of the root node are lesser, and all elements to the right are greater. This goes for each of the subtrees as well. Here is a demonstration on how elements are inserted into the tree. Starting with the first element 10, we insert that as the root. Retrieving the second element, 5, we compare it to the root node and see that 5 is in fact less than 10, so we insert it into the left subtree. 15 is not less than 10, so we will insert it into the right subtree. 7 is less than 10, but greater than 5, so we will insert it as a leaf in 5's right subtree. Moving on to 6, the last element, well, you get the picture. An important quality about a binary search tree is that all nodes remain in their current positions, except with the node to be added is inserted as a leaf. So what does this look like in code? First, we will instantiate our bare-bones BST class in a main method, creating an empty binary search tree. We will implement add, being a method that takes in one parameter, the element to add into the tree, and in this case an integer of 10. Trees are a recursive data structure, which is a structure that is partially composed of smaller or simpler instances of that structure. Well, let's see that for ourselves. In this given tree, we can see that the root contains both left and right subtrees. Looking at the root of the left subtree, it also has a left and right subtree, and this goes for every other node in the tree. Because of its recursive nature, we will use a helper recursive method to add the element. Remembering that all nodes are added as leaves, we can set the base case to return a new node only when we encounter a null root. Otherwise, we will continue down the tree, recursing either left or right, depending on the data relative to the root of the subtree being compared. Once the new node is created, the tree is rebuilt with the new element added as a leaf. So how does this recursion work with adding an element? We will add 3 elements to an empty tree in this example. Upon instantiating the BST class, we set the root node equal to null. We call addRec, passing the null root node and int5 as parameters, pushing the function onto the call stack. The root is in fact null, so we create a new node with 5 as the data and return that as the root of our updated tree. To add an element 1, we push the function call with the root and data to add to the call stack. The root is not null, so we continue down our function. 1 is less than 5, so we recursively call addRec with the current root node's left child as the root. Entering the function again, the root is null, so we create a new node of 1 and return it to the previous function call, updating node 5's left subtree reference, and finally returning the root. Adding our last element, 3, we call addRec with node 5 as the root and 3 as our data. The root is not null, but the data is less than the root's data. So we call addRec with the left child of node 5 as the root of the subtree to inspect. We go through the function again and see that 3 is greater than the current root node's data, 1, so we call addRec again with arguments null and 3. The root is null, so we create and return a new node to the previous function call, updating node 1's right subtree reference to node 3, and then returning node 1 to set node 5's left subtree reference, and finally returning the root node. If you enjoyed this video, please like and subscribe for more tutorials on computer science subjects.